Hello friends, now we'll start the second part of exercise 10.1. In this video, I will explain all the examples from the exercise 10.1. In my first part, I had explained all the basic concept and formulas. The link of that video I will give in the description box as well as comment section. Now let us start. Draw a quadrilateral in Cartesian plane whose vertices are minus 4, 5, 0, 7, 5, minus 5, minus 4, minus 2. Also find its area. Okay. Now this is the Cartesian plane. I draw the A, B, C, D. The first vertices here is the A, B, C and D. Now we'll find out the area of triangle first of all ABC. Okay. Vertices are A. The first vertex is the minus 4, 5. B 0, 7. C 5, minus 5. Now here the coordinates are x1, y1, x2, y2 and x3, y3. Now the area of triangle ABC that's equals to 1/2 in mod of x1 in bracket y2 minus y3 plus x2 in bracket y3 minus y1 plus x3 in bracket y1 minus y2. Okay, this mod is completed. Next 1/2 x1 is minus 4, y2 minus y3 that is a 7 minus in bracket minus 5 plus x2 is a 0 in bracket y3 minus y1 minus 5 in bracket again minus 5 plus x3 is a 5 in bracket y1 minus y2 that is 5 minus 7 overall more sign is completed. That's equals to 1/2 minus 4, it is a 12 next plus 0 and 5 into in bracket minus. Okay, now the next 1/2 minus 4 into 12 minus 48 and 5 into minus 2 minus 10 that's equals to 1/2 minus 58 is equals to 1/2 into 58, and that's equals to 29. Therefore, area of triangle ABC, that's equals to 29 unit square. Now we find out the area of triangle ACD. Okay. The first vertices A is -4, 5, C 5, -5, this is the C vertices, and D -4, -2, -4. Now here x1, y1, x2, y2, x3, and y3. Again, the area of triangle ACD, that's equals to 1/2 in mod of the first is x1 bracket y2 minus y3 plus x2 in bracket y3 minus y1 plus x3 in bracket y1 minus y2. Bracket is a completed. Now substitute the values. Here 1/2, x1 is -4, y2 minus y3, that is -5 minus in bracket -2 plus x2 5, y3 minus y1 -2 minus 5, x3 is a -4, y1 minus y2 5 minus in bracket -5. Okay, here 1/2 -4, and here you will have -5 plus 2, 5 into -7 -4 into in bracket 5 plus 5. Now the calculations 1/2 -4 into -3, next is a -35, and here -4 into 10, and this equals to 1/2 12 minus 35 minus 40, and overall we will have 1/2 12 minus 75. Here 1/2, and we have minus 63, and that's equals to 63 upon 2. Therefore, area of triangle ACD, and that's equals to 63 upon 2 unit square. Now we want to find out the area of this quadrilateral ABCD. Therefore, area of quadrilateral ABCD, and that's equals to area of triangle ABC plus area of triangle ACD. Now here's some. First is 29 plus 63 upon 2. Okay. And here the sum is, first is 29 into 2, 58 plus 63 upon 2, that is nothing but 121 upon 2, and hence the area of quadrilateral ABCD, that is equals to 121 upon 2 unit square. Again, you can see this here, question on the graph paper, and finally the solution. Okay, now the next question. Now the second problem, the base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is the origin. The midpoint, if we consider AC as the base, its midpoint is the origin. Okay, and its coordinate of the origin is a 0, 0. Therefore, the length of base is 2A. Therefore, OA, here is a small a and the small. As the triangle is equilateral, all sides are equal. First, we consider the case A, B, C. Therefore, the length of the side AB is a 2A. Length of the side BC, that is also 2A. Okay. Now we want to find out the vertices of the triangle ABC. This is the first. The triangle may be here, that is the vertex B dash on the negative x-axis. Okay. Now we'll find out the vertices of this triangle. It's clear that the A vertices is, A point is on the y-axis, therefore its x coordinate is 0 and y coordinate is A. Okay. Now the coordinate of the C, it's again the y-axis, x coordinate is 0 and y coordinate is a minus A. Okay. Now to find out the coordinate of the point B. Okay. Now the triangle ABC, this is the equilateral triangle. Okay. And the here x-axis and y-axis, the angle between them is a 90 degree. Here we consider the triangle AOB. This is the right angle triangle, and we know that the angle of the equilateral triangle, measure of this angle is 60 degree, and the side opposite to angle 60 degree is root 3 by 2 times the hypotenuse, and so that we will get here the OB. Okay. Therefore, here we write here the vertices of triangle ABC. The first vertices of the triangle A is 0, A. Second, C is 0, minus A. To find out the vertices of the triangle ABC, to find out the vertex B, here we consider vertex of B, consider triangle AOB of AOB, that is the measure of angle BAO that is equals to measure of angle BAC is equals to 60 degree. These are the angles of equilateral triangle, and therefore in triangle ABO, what's happening here? That is the side opposite to angle 60 degree is a root 3 by 2 times the hypotenuse. Therefore, OB is equals to root 3 upon 2 into AB. Okay. And what is the reason? The reason is that side opposite to 60 degree. Okay. And therefore here OB is equals to root 3 upon 2 length of AB, that is the side of equilateral triangle, that is equals to 2, and therefore it is root 3A. OB is root 3A, and therefore the coordinate of the point B, its x coordinate is a root 3A and 0. What about the B? This figure is a symmetrical, therefore the coordinate of the point B is a minus root 3A. Therefore the vertices of the triangle, the vertices of triangle ABC are vertices of A is, see this here, A is 0A. What about the B? B is, here I will write here, root 3A comma 0. Okay. B root 3a comma 0 and C is 0 minus a, and the triangle A, here is a B dash C R. A and C are the same, therefore A is a 0a, B minus root 3a 0 and C is the as it is. Okay. Therefore, it's very simple problem. You can apply from the Pythagoras 30, 60, 90 degree theorem and you can find out this OB, okay, as it is equilateral triangle. Now the next problem. Now the next question, find the distance between P x1 y1 and Q x2 y2. But when PQ is a parallel to y-axis, PQ is a parallel to x-axis. Now solution. Now this is the x-axis. So x dash. Next is y-axis. Y-O, y dash. The point are P, x1, y1, and here is a point Q, the x2 and y2. Now as the line is parallel to y-axis, its x coordinates are equal. Okay, therefore this as line segment PQ is parallel to y-axis. Therefore, x1 is equals to x2. Therefore, by distance formula, PQ is equals to in root of x1 minus x2 bracket square plus y1 minus y2 bracket square, and here both are the same, therefore x1 minus x1 bracket square in bracket y1 minus y2, it's a bracket square. Overall, here you will get 0 plus in bracket y1 minus y2 bracket square, and that is y1 minus bracket square. Therefore, the distance PQ, that is equals to in mod of y1 minus y2 when PQ is a parallel to y-axis. Now we find out the PQ when it is a parallel to x-axis. Now in second case, when PQ is a parallel to x-axis, coordinate of P is x1, y1 and Q is x2, y2. When a line is parallel to x-axis, its y coordinates are equal. Okay. Therefore, I will write here when line is parallel to x-axis, its y coordinates are same. Therefore, here y1 is equals to y2. Therefore, again by distance formula, PQ is equals to in root of x1 minus x2 bracket square plus y1 minus y2 bracket square. Yeah. What's happening? y1 is equals to y2, x1 minus x2 bracket square. Now here both are equal. y1 minus y1 bracket square is equals to in root of x1 minus x2 bracket square plus 0. Therefore, PQ is equals to in root of x1 minus x2 bracket square, and this nothing but mod of x1 minus x2, and therefore the distance PQ is equals to mod of x1 minus x2 when the line is parallel to x-axis, the difference of x coordinate. Okay, and when the line is parallel to y-axis, then the distance between that 2 points is nothing but the difference of the y coordinate. You can see this again. Now the next problem. Find a point on the x-axis which is equidistant from the point 7, 6 and 3, 4. Here the point on the x-axis be P. Let point on x-axis is, as the point is on x-axis, its y coordinate is 0, and suppose that it is a comma 0, and the other points, the first point is a 7, 6 and B is 3, 4. The point P is equidistant from A and B. Therefore, here we have AP is equals to BP. Okay, AP is equals to BP. Therefore, by the distance formula, here we have the AP distance. Okay, this is the 7, that is A minus 7 bracket square for the AP. First of all, A minus 7. In the next bracket, 0 minus 6, difference of y coordinate, 0 minus 6 bracket square. Now, on this side, the BP. Okay. Again, the difference of x coordinate, A minus 3, A minus 3 bracket square plus, next is 0 minus 4 bracket square. Now squaring on both sides, therefore squaring on both sides, you will have A minus 7, it's a bracket square, minus 6 square, 36, okay, A minus 3 bracket square. Here the minus 4 square means what? It is a 16. Therefore expand this here. A square minus 14 plus 7 square, 49 plus 36. A square minus 6a plus 9 plus 16. Okay. Here a square and a square get cancelled. Here you will get, therefore, minus 14a, and here 49 plus 36. Therefore, it will get here 85 and minus 6a plus 9 plus 16, 25. Therefore, 85 we can simplify. 85 minus 25, and that's equals to 14a minus 6a. But 85 minus 25, here you will get 60, and 14a minus 6a will get here 8a, and therefore a is equals to 60 upon 8, and this equals to 4 2s are 8, 4 1s are 4, and 4 5s are 20. Therefore, it is a 15 upon 2, and hence the answer A is equals to 15 upon 2. Therefore, we have the coordinate of the point P, which is on the x-axis. Therefore, the coordinate of P, which is A0, and that's equals to 50 upon 2. Okay, this is the point P, whose distance from A and B, these other 2 points are equal. You can see this also here. Now the next problem. Find the slope of a line which passes through origin, means we know the one point which is the 0 and 0, and the midpoint of the line segment joining the point P 0 minus 4 and B 8 4. Now the another point for another point find midpoint of PB. Okay, the coordinate of the point P is 0 minus 4 and B is 8 and 0. Line passes through the point, that is the origin, and the midpoint of these 2 points. Therefore, by midpoint formula, by midpoint formula. Suppose that the point is C. Okay, the point is C. The midpoint formula is x1 plus x2 upon 2, that is a 0 plus 8 upon 2. Next is a y1 plus y2 upon 2 minus 4 plus 0 upon 2. Okay, therefore the point C is 4 minus 2. Okay, and now slope of, we want to find out the slope of line which passes through the origin. Okay, slope of AC. Slope of AC. Okay, and what about the A? A is the origin. Slope of AC, that's equals to the difference of y coordinate upon difference of x coordinate, that is a minus 2 minus 0. Okay, x1, y1, x2 and y2. y1 minus y2 upon x1 minus x2, which is the 4 minus 0, that is equals to minus 2 upon 4 is equals to minus 1 upon 2, and hence the slope of line passes through origin and midpoint of which are the points P 0 minus 4 and B 8 0 is minus 1 upon 2. Okay, let's see this. The first point is origin, another point, find out the midpoint, then the slope of AC, and this is the answer. Now the next problem. Without using the Pythagoras theorem, show that the points 4, 4, 3, 5, -1, -1 are the vertices of a right angle. Now here we denote the coordinate A 4, 4, B 3, 5, and C -1, -1. Now in Pythagoras, it's a right angle triangle. We'll find out the slope of AB, BC, and AC. The product of any two is a slope of the product of any two segment AB or the BC or the AC is a -1. Then that two segments are perpendicular to each other, and we can show that the one angle of that triangle ABC is a 90 degree. Now first we find the slope of AB. Slope of AB. Okay. Now the difference of y coordinate upon difference of x coordinate. 4 minus 5 upon 4 minus 3. Okay. And this equals to -1 upon 1, and that's equals to -1. This is the slope M1. Next, slope of BC. Okay, slope of BC, and this is the M2. Okay, the difference of y coordinate upon difference of x coordinate. 5 minus in bracket -1 upon 3 minus in bracket -1, and this equals to 5 plus 1 upon 3 plus 1, that is a 6 upon 4. Again simplify, you will get 3 upon 2, and this is the M2. Now the slope of AC, and that slope is a M3. Okay, again the difference of y coordinate upon difference of A. 4 minus in bracket -1 upon 4 minus in bracket -1, and here you will get minus minus plus, minus minus plus. 4 plus 1 is a 5 upon 5 is 1, and this equals to M3. If you observe that the slope of AB is a -1 and the slope of AC is a +1, and both of them have the A point is a common. But here, hence AC is perpendicular to AB. Okay. Here A vertex whose coordinate is 4, 4 is common. Okay. Therefore, angle BAC is equals to angle BAC equals to 90 degree. Okay, and therefore the 4 4 second 3 5 and -1 -1 are vertices of are, are the vertices of the right angle triangle. Okay, it's very simple. Find out the slope. Product of slope as -1, and therefore they are the vertices of the right angle triangle. Now the next problem. Find the slope of the line which makes an angle of 30 degree with positive direction of y-axis measured anti-clockwise. Okay, now see this figure. This is the line L. It makes an angle of 30 degree in a positive direction of the y-axis. Okay, now we want to find out the slope of this line L. Now here is a 30 degree, and what about the measure of this angle? It is a 90 degree. Therefore the line makes an angle of line L makes an angle of 30 degree plus 90 degree. Okay, and that's equals to 120 degree. We want to find out the slope of the line. Okay, therefore slope of line L, that's equals to tan of 120, and here tan of 120, it can be written as 90 plus 30 degree, and that's equals to minus cot of 30 degree, and the value of cot 30 is root 3, therefore here minus root 3. Therefore slope of line is minus root 3. Now the next problem. Find the value of x for which the point x minus 1, 2, 1, 5, 4 are collinear. Now here the points are, the first point is x minus 1, B point is 2, 1, and third point C is 4, 5. As the points are collinear, the slopes are equal. Therefore, slope of AB is equals to slope of BC. Okay. Now here we'll find out their slopes. Again, difference of the y coordinate. First, AB -1, -1. Difference of x coordinate. X -2. Here, the slope of BC 1 -5. And the next is a 2 -4. Okay. Here you will get -2 upon x -2. Here you will get -4 upon 2 -4. Okay. That is equals to -2. And here you will get minus division, that is a plus 2. And therefore -2 upon x -2 is equal to 2. Now the simplification. Okay. -2 upon 2 is equals to x -2. Then what is here? -1 is equals to x -2. And therefore x is equals to -1 plus 2, that is equals to 1. Therefore here x is equals to 1. Therefore the answer x is equals to 1. You can see this problem answer. Now the next problem. Question number 9. Without using distance formula, show that points -2, -1, 4, 0, 3, 3 and -3, 2 are the vertices of a parallelogram. Okay. Now here we will first of all draw the figure. These are the vertices A, B, C, D. Now we'll find out the first of all slope of AB and the slope of CD. Okay. Slope of AB is equals to difference of y coordinate upon difference of x coordinate, -1 -0. Okay. -1 -0 -2 -4. Okay. -2 -4. And here you will get -1 upon -6, and that is equals to 1 upon 6. Therefore slope of AB, in bracket we treat it as m1, and that is equals to 1 upon 6. Now slope of CD, here difference of again the y coordinate, 2 -3, the 2 -3 upon -3 -3, and that's equals to -1 upon -6 is equals to 1 upon 6. Okay. Therefore here we write slope of CD in bracket m2, that is equals to 1 upon 6. Therefore here slope of AB is equals to slope of CD. Therefore segment AB is parallel to segment CD, and this is the first one. Now we find out the slope of BC and AD. Slope of BC, that is equals to slope of BC, again 0 minus 3 upon 4 minus 3, that is equals to minus 3 upon 1, which equals to minus 3. Slope of AD, that is equals to slope of AD minus 1 minus 2 upon minus 2 minus in bracket minus 3. Okay, and this equals to minus 3 upon minus 2 plus 3. Overall, minus 3 upon 1, and that is equals to minus 3. Hence, slope of BC is equals to slope of AD. Hence segment BC is parallel to segment AD. This is true. Therefore, from 1 and 2, in quadrilateral ABCD, opposite sides are parallel. Therefore, quadrilateral ABCD is parallelogram. Okay. Can see this. First, find out the slope of AB and CD. They are equal. Next, slope of AB, slope of BC and slope of AD, minus 3, minus 3. Again, they are parallel. And hence in the quadrilateral, opposite sides are parallel. Hence it is a parallelogram. Can see this also. Next problem. Find the angle between the x-axis and the line joining the points 3, minus 1, 4, minus 2. Okay, now see this figure. We can find out the slope of a line when the angle of inclination is given, and also when the 2 points on that line is given. Okay, of that line is given. Now here we have the 2 points A and B. Therefore, tan theta is equals to m, that is slope, and this m is nothing but the y1 minus y2 upon x1 minus x2. The first coordinate 3 minus 1 here is x1, y1, x2 and y2. Okay. Therefore, we want to find out that inclination made by that line with the positive direction of the x-axis. I will write here the y1 is minus 1, y2 is minus in bracket minus 2, there is x1 minus x2. x1 is 3 minus 4. This minus and minus, that will become plus. Okay. And this divided by minus 1. And therefore, tan theta is equals to 1 upon minus 1, and that is equals to minus 1. Here, tan of theta is equals to minus 1. That is a minus in bracket tan of pi by 4 or 45. Okay. Therefore, tan theta is equals to tan of pi, that is a 180 minus 45. Okay. And that's equals to tan of 135. Okay. And hence theta is equals to 135. Okay. Therefore, the angle between the x-axis, therefore the angle between x-axis and line joining the points, line joining the points, line joining the points 3 minus 1 and 4 minus 2 and 4 minus 2 is 135. Okay, this is the answer. You can see this. Now the next problem. The slope of a line is double of the slope of another line. If tangent of the angle between them is 1 by 3, find the slopes of the lines. Okay, now the solution. Let M1 and M2 be the slopes of two lines such that m1 is equals to 2 times m2. Okay. Now suppose m2 is equals to m. Okay. m2 is equals to m. Therefore, m1 is equals to 2 times m. Okay. And the tan of theta, that is equals to m, is equals to in mod of m2 minus m1 upon 1 plus m1 into m2, and this equals to m2 minus m1. m2 is m minus m1, which is the 2m, 1 plus m1 into m2. m1 is 2m, m2 is m. Okay, therefore here, and this tan theta, that is the angle between them, is a 1 by 3. Therefore we'll write here 1 by 3, and that's equals to m minus 2m. You will get here minus m, and to the denominator 1 plus 2m square. Okay. And again here, therefore 1 by 3, as there is a mod sign, it is a plus 1, m upon 1 plus 2m square. Okay, we draw the mod sign, then we have, that is a m is equals to 1 plus 2m square, that is equals to 1 by 3, or m upon 1 plus 2m square is equals to minus 1 by 3. Here we have the case 1, when m upon 2m square is equals to 1 by 3. We will evaluate this cross multiplication. 3m is equals to 1 plus 2m square, and therefore 2m square minus 3m plus 1 is equals to 0. Therefore 2m square minus 2m minus m plus 1 is equals to 0. Take the 2m as a common. In bracket, m minus 1 minus m common, in bracket m minus 1, that's equals to 0, and therefore in first bracket m minus 1, in second bracket 2m minus 1, that's equals to 0. Therefore m minus 1 is equals to 0 or 2m minus 1 is equals to 0. Therefore, m is equals to 1 or 2m is equals to 1, that is m is equals to 1 upon 2. Therefore, m is equals to 1 or m is equals to 1 upon 2. Again here, but m2 is equals to, we have substituted here, m2 is equals to m2 is equals to m, and that is equals to 1, and m1 is equals to 2 times m2, that is equals to 2 into 2 into 1, that is equals to 2. Therefore, what is the first pair? The first pair is a 1 and 2. This is the first pair. This is the first one. Okay. Now the next. M is equals to 1 upon 2. Therefore, m2 is equals to m is equals to 1 upon 2, and m1 is equals to 2 times m2, that is equals to 2 into 1 upon 2, and that is equals to 1. Therefore, the second pair, second slopes are 1 upon 2 and 1 upon 2 and 1. Okay. Yeah. This is the first case. What about the second case? That is the m upon 1 plus 2m square is equals to minus 1 by 3. Now here, case 2, m upon 1 plus 2m square, m upon 1 plus 2m square is equals to minus 1 by 3, and therefore here we have the cross multiplication, 3m minus in bracket 1 plus 2m square, therefore 3m minus 1 minus 2m square, and again these are 2m square plus 3m, okay, plus 1 is equals to 0. Now the factorize this, 2m square plus 2m plus m plus 1 is equals to 0. Okay, and therefore we can take 2m as a common, then in bracket m plus 1, 1 in bracket m plus 1, and that's equals to 0. Therefore, m plus 1, 2m plus 1, that is equals to 0, and therefore m plus 1 is equals to 0 or 2m plus 1 is equals to 0. Therefore, m is equals to minus 1 or m is equals to minus 1 upon 2 if we evaluate it. Again, when m is equals to minus 1, that is m2 is equals to minus 1 and m1 is equals to 2 times m2, that is equals to 2 into minus 1 is equals to minus 1. Therefore, what are the slopes m1 and m2? Here 2 into minus 1, it's a minus 2. It is a minus 2. Therefore, slopes are minus 1 and minus 2. When m is equals to minus 1 upon 2. Okay. Therefore, m2 is equals to minus 1 upon 2 and m1 is equals to 2m2, that is equals to 2 into in bracket minus 1 upon 2. Therefore, m1 equals to minus 1 and m2. Hence, slopes of lines are slopes of lines are 1, 2, or next is 1 upon 2, 1, and 1, or minus 1, minus 1, and minus 2, or minus 1 upon 2 and minus 1. Okay. Now the next question. A line passes through x1, y1 and hk. If slope of the line is m, show that k minus y1 is equals to m in bracket h minus x1. It's very easy question. Now the solution. A line passes through x1, y1 and hk. Okay. Therefore, slope of line is equals to difference of y coordinate upon difference of x coordinate. That is, first is k minus y1 upon h minus x1, and that's equals to m. Therefore, after the cross multiplication, k minus y1 is equals to m in bracket h minus x1. Okay, and this is we want to prove. Okay. Now the next question solution. That is, if 3 points h0, ab and 0k lie on a line, then show that a upon h plus b upon k is equals to 1. Now the solution. Okay. The points are, suppose that the points are, first point is a h0, b, ab and c 0k. As these points lie on a line, these points lie on a line. Therefore, slope of AB is equals to slope of BC. Okay. Now the slope of AB, therefore 0 minus B upon H minus A is equals to. Now the slope of BC, here B, difference of y coordinate, B minus K upon A minus 0. Okay. And therefore here we have, that is, B upon H minus A is equals to B minus K upon A. Okay. Now we evaluate this. Therefore, cross multiplication A into B is equals to, in bracket, H minus A into B minus K. Therefore, H into B, HB, H into K minus HK minus AB and plus AK. Okay, here is the AB. One thing is that here minus and minus. Minus AB and minus AB on both sides get cancelled. Therefore, here we can write HB plus AK, HB plus AK is equals to HK. Now, dividing on both sides by HK, Therefore, you will get HB plus AK upon HK is equals to HK upon HK. Here HK get cancelled, HH get cancelled, B upon K plus A upon H. Okay, that's equals to 1. And hence we want to prove this. So you can see this. As the points lie on the same line, therefore the points are collinear. Therefore, slope of AB is equals to slope of BC. And substitute the values, you will get the answer. Problem is very easy. Now the last problem. Consider the following population and year graph. Find the slope of the line AB and using it find what will be the population in year 2010. Now we'll first find out the slope of AB. Okay. Now slope of AB. The coordinate of A is 90, 85, 92. Coordinate of B is 19, 95, and here it's a 97. Okay. Therefore, slope of AB, that's equals to difference of x coordinate CBSC 92 and 97. Okay. 97 minus 92 upon 1995 minus 1985. Okay, their subtraction is 5 upon 10, and that is equals to 1 upon 2. Therefore, the slope of line AB is 1 upon 2. Now next, find what will be the population in year 2010. Let C 2010 and here A, B point on that line. Therefore, slope of AB is equals to slope of BC. Okay. Now we know the slope of AB. That's 1 upon 2. Now the slope of BC. Okay. B is a point. The first 97 and okay. It is the difference of y coordinate means what? A minus is 97 upon. Next is a 2010 minus 1995. Okay, this is the A upon 97, A minus 97, and here the subtraction. We will get here 2010 minus 1995. Here is a 15. Therefore, 1/2 a minus 97/15, that is equals to, here cross multiplication, or you can write here 15/2 is equals to a minus 97. 15/2 means what? 7.5 a minus 97. Okay, and therefore a is equals to 97 plus 7.5. okay, and therefore here its sum is 104.5 is. Therefore the population in year 2010 will be, therefore population in year 2010 will be 104.5. okay, and this way we have completed this question as well as the first exercise 10.1. Now we'll see in the next video. Till then, goodbye.